Activity selection problem. Activity selection problem is a problem that can be solved by greedy strategy. Let us first see what is the problem statement and then we'll see what is the approach to be taken to solve this problem and what are the steps to be followed. So this is the problem statement. There are n activities along with their start and finish times. What is the goal? What are you going to do with this? You want to find out the maximum number of activities that can be performed given that there is only one person, there is a single person who is performing all these activities, and this person can perform a maximum of one activity at a time. So you are having n activities, you are given the start and finish times, and what do you want to do? You want to find maximum number of activities that can be performed given that there is only one person and he can perform only one activity at a time. Let us see what approach are we going to take. We already said we are using greedy strategy here. So what is the greedy approach in order to solve this problem? The greedy approach is always pick the activity which is having the nearest finish time such that the start time of this activity is greater than the finish time of previous activity. So let us say you are having many activities. I'll use each activity will be represented by start and finish time. So S1, F1 can be start and finish time of first activity. Similarly, let us say you are having a lot of activities like this. So how will you select the activity? You have to find whichever activity is having the smallest finish time, that is the nearest finish time. Let us say activity 2 is having nearest finish time. What will you do now? The first activity can be selected as it is because there is nothing else to look at. But while you are selecting the second activity, you have to make sure that start time of this activity is greater than the finish time of previous activity. Why is this? Because we already said a person can only do one activity at a time. So if the start time overlaps with the finish time, that means that is the finish time of previous activity. That means both the activities will have to be performed at the same time, which is not possible. So you can select an activity only if its start time is greater than the finish time of previous activity. Okay. So let us first see what are the steps to be followed in order to solve this. So the first step is you have to sort the activities. Why should you sort? We already said we are selecting activities by the finish times. So you want to see which activity is having the smallest finish time. So because of this, you are going to sort the activities by their finish time. Sort activities by their finish times. This is the first task. Once you sort, you have all these activities sorted according to finish times. What is the second step? You want to select the first activity. Select first activity, and after you select the first, see the first activity can be selected as it is because you are not having any previous activity because of which start time doesn't matter here. But from the next activity you have to be careful of the start time. So from the next activity, what should you do? You should check about the start time. If the start time of this activity is greater than the finish time of previous activity, if this condition is satisfied, then you can select the second activity. If it is not satisfied, you should skip the second activity, move on to the third activity. So you should continue this process till you go through all the activities that are present. That is, you are already having it sorted according to the finish times, and through this list you are going. What do you do? The first activity you will select as it is. After this, for all the other activities, what will you do? You will make a check, that is the start time of this activity larger than or greater than the finish time of previous activity? If this is satisfied, you will select this activity. If it is not satisfied, you will reject this activity. So using this process, if you go through all the activities which are sorted according to finish times, this will give you the count of total activities that can be performed. So one thing we have to do here is, in the previous lecture, we discussed that in order to solve any problem by greedy strategy, there are two properties that are to be followed. So understanding these two properties means you know when to use a greedy strategy and when to not use a greedy strategy. So let us see whether the two properties that we discussed, are they followed in this case or not. So if they are followed, then only it makes sense in order to use a greedy strategy. So there were two properties that we discussed. First property is greedy choice property and second property was optimal substructure. So let us see whether greedy choice and optimal substructure are followed in this case or not. Okay. So the first property is greedy choice property. Is greedy choice property followed here? What does greedy choice property say? It says making locally optimal solutions at each step will help in achieving what? The global optimum solution. So you will be making locally optimal choices at each step, and this will help you in finally achieving the global optimum solution. This is the greedy choice property. Let us see whether this property is followed in the way we are solving activity selection problem. What are we doing here? We are selecting the activity that finishes the earliest. So let us say we selected some particular activity. What is the speciality of this? Let us say this is the first activity we are selecting. This finishes before any other activity. What do we do by doing this? By doing this, we are leaving maximum remaining time for the remaining activities, for the rest of activities, ensuring that the best chance of fitting more activities is present there. So when you select the first activity as the activity which is going to finish the earliest, you are leaving maximum time for the remaining activities to work on. This means the greedy choice property is followed, because when you made the locally optimal choice, that is selecting the activity with least finish time, when you made the locally optimal choice, you are helping yourself achieve the global optimum solution. How? Because you want to fit maximum activities. This is your task. So in order to fit maximum activities, you are leaving maximum remaining time for the rest of activities by choosing an activity which is having least finish time among the list. So this is the logic by which greedy choice property is followed. So our first property is already followed. The next thing is, let us see whether the second property, that is optimal substructure, is it followed or not. So what about the optimal substructure? As per the optimal substructure property, what does it say? You should be able to break the problem into smaller subproblems, and the solution to these subproblems should finally give you the final solution. So what are you doing here? After, let us say, you selected one activity, what happens? The problem reduces to finding the optimal solution for remaining activities. Let us say you selected one activity here. After this, the problem reduces to finding the optimal solution considering only the remaining activities. So one thing you have to note here is the problem that we found out here, that is after selecting the first activity, whatever problem is remaining, this problem is identical to the original problem we were solving. How is it identical? Because the original problem said you have complete period of time and you want to fit in maximum number of activities inside this period of time. What is the new problem statement? After the selection of first activity, you already selected the first activity And in the remaining time, you have the same problem statement, that is, fit maximum number of activities possible in this remaining time period, which means what are you doing? You are breaking this to a smaller problem which is exactly same as what you initially solved. This means the optimal substructure property holds. You can break the overall problem into smaller problem which can be solved by greedy strategy, and you can reach the final solution. So this means both the greedy choice property as well as optimal substructure property are followed in this case. When both are followed, what can you do? You can use the greedy strategy in order to solve this problem. So this is how you understand or you make sure that greedy is applicable in this problem. What we'll do is, let us do two things. One, we have to take an example and understand this. Also, we need to understand the time complexity of this problem. So let us first look at the time and space complexity, because we can directly find it from here itself. So the first step is sorting all the activities. Sorting takes order of n log n time. So we already know this from our previous algorithm lectures, that for sorting we generally take order of n log n time. And what is the next thing? You're selecting the first activity. It takes only order of 1 time. And then for all the remaining activities, you have to do this. You have to check whether the start time of that activity is greater than the finish time of previous activity. If this is followed, then you can select this activity. So basically, through each of the activity, you are going and doing an operation which takes order of 1 time. So because you are going to all the activities, it takes order of n time. So what is the total time taken? Order of n log n is the largest term here. So the total time complexity taken is order of n log n. So this is the time complexity of activity selection problem. What about the space complexity? The space complexity is order of 1. Why is it order of 1? Because you are not using any extra space here. So the sorting, you are going to consider that we are going to do in place sorting. So you will be sorting it with the given array itself. And what about the remaining steps? You are just looking into this sorted array. You are selecting activities one by one. So you are not using any extra space. So because of which, space complexity is order of 1 and time complexity is order of n log n. Now let us just take an example. Let us take few numbers and understand how this activity selection problem actually selects the activities that are required. So let us consider these are the start and finish times 1 and 5. So what I'm writing this 1 and 5, you can take it as any units of time. It can be seconds, minutes or whatever. So it just means this activity starts at the first minute and finishes at the 5th minute. Okay. So let us say second one is 3, 4. That is, it starts at 3rd minute and ends at the 4th minute. Let us say you have 0, 9, 8, 9, and let us say 6, 8, 5, 8. So these are the activities that we have. What do we have to do? We have to find maximum number of activities that can be carried out. So here you have a total of 6 activities. Let us see what is the maximum number of activities you can carry out. The first step is to sort. So you are going to sort these activities according to finish times. So see the finish times here, and you are going to sort according to those finish times. Let us see what is the sorted list. The least finish time here is 4, which is of 3, 4. So this is my sorted list. Okay. After 3, 4, which has the least finish time? 1, 5, because 5 is the least finish time after 4. After this, which is the least finish time, both of these are having 9, both of these are having 8. So we'll choose 8 as the least finish time. So you have 5, 8, you have 6, 8, then you have 8, 9 and 0, 9, right? 0, 9 and 8, 9. So these are the activities that you have in the sorted list. What is the next step? You have to select the first activity. So you are going to select first activity, which is 3, 4. This is already selected. What is the third step? For each of the remaining activities, what do you have to do? You have to check whether the start time of this activity is greater than finish time of previous activity. So how do you make this check? For 1, 5, 1, 5, you have to check whether the start time, which is 1, is it greater than the finish time of previous activity, that is 4? No, it is not, which means you cannot choose this activity 1, 5. If you choose it, it will overlap with the activity 3, 4, which is having a smaller finish time. So 3, 4 actually gets priority here. What is the next activity? Next is 5, 8. 5 is the start time, which is greater than 4. It is correct. So because start time is greater than the start time of previous activity, you can select 5, 8. What is the next activity? Next is 6, 8. So considering 6, 8, again the same problem occurs. 6, which is the start time of this activity, is it larger than the finish time of previous activity, which is 8? No, it is not, because of which you cannot choose 6, 8 as well. Next is 0, 9. What about 0, 9? Start time is 0 and you can't have this because 0 is not greater than the finish time. 8 is the finish time. 0, is it greater than 8? It is not. So because of which, if you select 0, 9, it will overlap with the existing activity, that is the previous activity, and because of this 0, 9 can also not be selected. What is the next activity? It is 8, 9. So this time, is 8 greater than the finish time of previous activity? 8 is actually equal to the finish time of previous activity. So one thing here is, when you have an activity which is having start time same as the finish time of the previous activity, generally you will pick it in activity selection problem. The reason is, let us say you are having these two activities. Okay, in this case, you are having 8 as the start and finish time. That is start time of present activity and finish time of previous activity. In such cases, generally you will pick this activity because instead of greater than condition, it is better to use a greater than or equal to condition. The reason is, let us say this activity, the previous activity, it finishes at 8. So you're generally considering that whichever with the point of time from which you are counting as 8, at this point previous activity will finish. What about the new activity? It will start from this point. So these are actually not overlapping. Whichever be the exact checkpoint at which you are pointing as time point 8, that is the point where the previous activity ends, and this exactly is the point where the new activity begins. So these are not overlapping, instead it is efficient utilization of time, because of which you will be selecting such activities. That is, if the start time of present activity is equal to the finish time of previous activity, you'll still select it. So in this activity selection problem, you can select a maximum of 3 activities. So we have seen that this is a problem which can be solved by greedy strategy. We saw the properties that are followed. What were the properties? Greedy choice property and optimal substructure property. So because these properties are followed, you can select greedy approach.